In this slide, we're going to discuss the question of when are two angles equal or equivalent. Now, this question actually really depends on which of the three meanings of the word angle we are actually using. So, if we use the meaning of the word angle, which is a geometric angle, then two angles are equal if they literally coincide. If we speak of their angle measures, that no longer needs to be the case. Right, because they're angle measures, these are numbers, and two numbers can be equal without you having the exact same configuration of a point and two rays. So to avoid the ambiguity of whether two angles that have the same measure are actually equal or not, we're going to introduce the term congruent. So we're going to introduce the term congruent. So two geometric angles are congruent, or if you wish equivalent, if they can be transformed one onto the other with a sequence of translations and rotations. So here are two angles. The way I've depicted them, they appear to have the same angle measure. So if you take that arc and you measure the length of the arc of the unit circle chopped off by this angle, you do the same with that angle, you're going to find that this arc here equals that arc. Okay, so the measures of these two angles are the same. Now, by definition, those two angles would be the same by this technical definition that we've given here. So those two angles will be congruent or equivalent if I can transform one onto the other with a sequence of translations, such as this one. So, of course, if the two angles are to be transformed into one another, their vertices must coincide. So here we go. I can transform one angle onto the other by pushing the vertex of one angle onto the vertex of the other, and then I'm also allowed to do a series of continuous rotations. There we go. And I have now transformed the first angle onto the second one. So that I demonstrated on a picture. But you're going to say, well, in the beginning you told us that the two angles were kind of equal because their angle measures are equal. So how does the notion of two angle measures being equal, so two lengths of arcs being equal, so how does that compare to this notion of equivalent angles? Well, the answer is the following. Two geometric angles are congruent if and only if they have equal angle measures. So whenever you give me two angles and their angle measures coincide, I can move one angle onto the other by translation and rotation. In fact, I showed you how to do it. You first translate the vertex of one to meet the vertex of the other, and then you rotate. Recall that the term angle refers to both geometric angle, which is the configuration of rays in a center, and their angle measure. And whether the word angle, which of the two distinct objects we're talking about, that really depends on context. So in other words, it's not specified. It's up to you as intelligent human beings to discern what I mean when I say the word angle. Do I mean geometric angle or the angle measure of such an angle? So in other words, if you hear a mathematician or non-mathematician say, well, these two angles are equal, however, you see that the angles are in two different positions in space, so they clearly do not coincide, they don't have the same rays and the same origins. So if you hear a person say, well, these two angles are equal, but they literally are not the same configuration, then you have to interpret their words as if they said that their two angle measures are equal. Or you have to interpret their words as if they said, I could take one of the angles and I could move it on top of the other angle with a series of translations and rotations. Or in other words, the two geometric angles are congruent. So when you hear people talk of equal angles, they either mean congruent geometric angles or equal angle measures of to geometric angles.